Hello, everyone. Good morning, afternoon, and evening. Dear authors and invited guests, welcome to Technical Session 7D. I am Pranjal Banage, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you to the 11th International Congress on Information and Communication Technology, ICICT 2026, in London, UK. The 11th edition of the conference is being organized in a hybrid mode. The physical event was held a day before yesterday in London, UK, and the virtual event is being held through Zoom from 25th to 27th February 2026. I hope you'll enjoy the knowledgeable and interactive session throughout the day. In this session, we have 6 presentations. Each presenter will be given 12 minutes for the presentations and 3 minutes for questions and answers. In 10 minutes, I'll raise a gentle reminder. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any queries or updates, then you can write it to me or to my co host in the chat box. Just before we start the session, I would like to introduce you all to the chair of this session. Let's start with Professor Kunuhiko Takamatsu. He's a professor of Institute Management in the Office of Strategy and Planning at the Tokyo Institute of Technology. His main work focuses on institutional research in the university and university reform in higher education through education informatics. I would like to invite you to give your opening remarks, sir.
Thank you. Today, now I'm looking forward to seeing you in this line. Thank you very much. So I enjoy. So please, the presenter will enjoy with me. Thank you.
Thank you so much, sir. Moving forward with our next session chair, Dr. Ishwari Raskar. She is an assistant professor at MIT ADT University in Pune, India, specializing in data science and the Internet of Things IoT. Her research focuses on mobile applications with OCR capabilities, wearable technologies, energy efficient sensor networks, and machine learning based risk assessment. Dr. Raskar is committed to advancing innovative research and fostering impactful learning and experiences for her students. I would like to invite you to give your opening remarks, ma'am. Then, since ma'am is not here, we'll be moving forward with our first presentation. She'll be joining us in the middle. Let's move forward with our first participant, which is Damia Fateh Al Kerbali. She'll be presenting her paper on a resilient hybrid PQ key establishment protocol combining LWE and NT-RU primitives. I would ask you to present your paper and start presenting your screen.
Yes, hello, everybody.
Hello. You may please share your PPT.
Yeah.
Yes. Pranjal, am I audible to you?
Yes, ma'am, you're audible.
Hi, Pranjal.
Hello, ma'am.
Presented it, please.
Hello, Pranjal, am I audible to you?
Yes,
This is
ma'am, you're
Ishwari
audible.
Raskar
Can I start to
from
present it?
MIT ADT University.
Yes.
Your voice is not audible. You are not audible to me. Just a second. I will join from headphone. Just a minute.
Can you see the presented?
Yes, ma'am, we can see your presentation.
Can I start?
Just a moment, ma'am.
Yes.
Damya, you may start with your presentation.
Yeah. My name is Damia Zuldi Fattah. I am a master's student in Ambar University. My paper is a resilient hyper post-quantum key establishment protocol combining learning with error and network primitive, supervised by Prof. Dr. Amar Dawood. Content, abstract, introduction, problem statement, work objective, literature survey, or proposed hyper learning with error and network model, result and analysis with experimental setup, and conclusion or reference. Abstract, the paper presents a hybrid protocol combining learning with error and degree truncated polynomial ring unit network to improve encryption security against last and the quantum attack. It utilized a network-efficient polynomial multiplication to enhance learning with error, resulting in independent key. The hybrid key encapsulation mechanisms integrated both encapsulation via HKDF, a Python simulation demonstrate the approach efficiently balance learning with error security and network speed, making it suitable for applications such as IoT, 5G and blockchain, while also competing well with the standalone post-quantum cryptography technique. And this, in the term of performance and scalability, ensuring manageable ciphertext size for key exchange. The hybrid key exchange protocol utilizes learning with error and network are crucial for post-quantum cryptography, offering strong security against quantum threat with efficient implementation, while learning with error schemes are robust against classical and quantum attack. They face challenges from hybrid dual attack network, also efficient has identified related to cyclomatic ring and a specific parameter set. Recent advancements include the development of strong multi-key and double network structure and hyper method for key encapsulation, such as optimizing network-based multi-key fully homomorphic enhancements such as optimization network-based multi-key encryption have resulted in efficient scheme that error growth. However, the security of hybrid protocol is reliant on the integrity of each component in distinguish choosing ciphertext attack. Secure double network key encapsulation algorithm have been created to ensure tight security without the need of complex operation. Problem statement: current encryption mechanism may not provide sufficient protection against last-based and quantum attack, and standalone post-quantum schemes such as learning or network individually present a trade-off between security strength and computational efficiency. Work objective to design and evaluate a hybrid key encapsulation mechanisms that combine learning with error and network in order to enhance security against last quantum attack while maintaining computational efficiency and reasonable ciphertext size. Many literature survey to enhance post-quantum security, particularly for a blockchain system, while last-based approach improve resistance against quantum attack challenges remain in key size, hardware computationally and efficiency. Research on hybrid attack show they can outperform a standalone attack on learning with error or network under certain conditions. However, effectiveness disagrees with higher dimension and Gaussian secret distribution. Undistinguished chosen ciphertext attack secure key exchange mechanism based on D-network was proposed, offering strong security against choosing ciphertext attack. The main drawback is increased key and ciphertext size compared to standard network schemes. Studies refining PKZ complexity analysis reduction with meeting in middle attack improve crypto analysis accuracy. Traditional security estimate may overlook particle implementation vectors. Analysis of netro GKP code indicated decoding remain computational.
Damya, are you still there? Damya?
Can you hear me? The internet was lost. Can you hear me?
Yes, Damya, we can hear
Sorry.
you.
Yeah. Sorry, this is Bobo. Because of the internet in Iraq was poor.
It's fine. You may
Can
continue with the presentation.
Can I share it?
Yes, you can.
I'm sorry. I'm so sorry. Analysis of network code indicated decoding remain computational hard to efficiency limitation and challenges in evaluating quantum security present. The proposed network problem marriage network and model learning with error simulation showing a hardness at least comparable to both potentially offering stronger long-term security. Overall, hyperless space construction strength boost quantum security, but the trade-off in efficiency, key size, and cryptanalytic complexity remain open research challenges. This is a table present a literature survey on public key exchange scheme employing less space and ring learning with error. Proposed hybrid learning with error and network model. This proposed model aims to combine the proven security of learning with error with the great efficiency of network into a single hybrid key exchange protocol. This automatically combine learning and network in the one hardness simulation. The hybrid protocol employs two distinct key encapsulation mechanisms. One for learning with error and the other key exchange mechanism from network. The final shared key is key make combine from learning with error and network. The protocol and include three algorithm: hybrid learning with error key generation, or hybrid learning with error network key encapsulation, or hybrid learning with error and network decapsulations. Algorithm hybrid learning with error network key in generation. The purpose generate public secret key for both learning and network to be used in hybrid model. This is the algorithm, and this algorithm purpose the sender uses the receiver hyper public key to encapsulate a single hyper shared secret using both schemes, then combine them using HKDF. And the last algorithm, hybrid network and learning with error decapsulations. The final hybrid shared key or failure result and analysis based on 20 iteration. Kyber achieved the best lowest handshakes latency 0.2199 second, high throughput 4.546 handshakes per second and smaller ciphertext size, making it ideal for real-time and IoT application. Netro show slightly better reliability in terms of success and network failure rate, making it suitable for high security environment where latency is least critical. The hybrid model provides stronger theoretical security but introduces a higher computational and communication overhead, resulting in lower throughput and higher network failure rate. Despite the overhead, the hybrid key encapsulation mechanisms remain practical for IoT and 5G when used primarily during the key establishment, followed by lightweight symmetric encryption. Performance was evaluated using matrices such as handshake time, throughput, success rate, and encapsulation failure rate, and communication overhead. This is stable the result hybrid learning with error and netro key encapsulation mechanism results of for average of 10 execution. Display the numbers of the الماتريسيز الافريج هاندشيك تايم ثروبوت and end-to-end handshake throughput الكريبتو only successful I am compare it with Kyber only Netro only and the hybrid Kyber and Netro the proposed model I designed it. A result and analysis the hybrid protocol exhibits comparable handshake time and success rate to individual post-quantum cryptography schemes such as Kyber and Netro, while offering benefits like reduced network failure rate and robust decapsulation despite large communication size, and its dual security asymptotation enable shorter ciphertext and enhanced security strength with lower resources requirements, make it advanced for secure post-quantum key exchange is surpasses standalone Kyber and Hyper by employing two hardness asymptotation, guaranteeing that session key recovery remains secure unless both primitives are compromised, unlike single post-quantum key encapsulation mechanism, which lose security upon the compromise of their single primitive. And this figure explains the result. Kybert and Netro only plus hybrid Kyber plus and Netro. Experimental setup, the underlying architecture use experimental setup for implementation of the experimented was Intel with 16 core and 15.71 gigabyte of RAM under Windows 10 and Python 3.10 for each protocol. There are 2,000 iteration, 200 iteration.
But your
yes.
time is up. I'd request you to conclude your presentation.
Okay. Conclusion, this final. The analysis of hybrid Kyber protocol indicates that design reducing result in theoretical optimally regarding security, but introduce undesirable overhead. This is enough. This is references and if any questions.
So, ma'am, do you have any questions for her?
Yeah. Thank you for all.
Thank you so much, Damya.
You're welcome.
Now, I would like to reintroduce another session chair. That's Dr. Ishwari Raskar.
Yes. Am I audible to you?
Yes, ma'am, you're audible.
Good morning.
Dr. Ishwari Raskar is an assistant professor at MIT ADT University, Pune, India, specializing in data science and the Internet of Things. Her research focuses on mobile applications and OCR capabilities, wearable technologies, energy-efficient sensor networks, and machine learning-based risk assessment. Dr. Raskar is committed to advancing innovative research and fostering impactful learning experiences for students. Ma'am, would you like to give some opening remarks?
Yes, yes. Thank you so much, Pranjal. So, good morning, everyone. So, it is my honor to serve as a session chair for the technical session 70 at ICICT 2026. So, I look forward to insightful presentation and meaningful discussions that will be contribute to advancement in the information and the communication technology. So, I would like to thank to Pranjal to invite me as a session chair. Thank you so much, Pranjal. So, the first, I think, first author is completed their presentation, right?
Yes, ma'am.
Okay. So can I ask some questions about that?
Yes, ma'am, definitely, definitely.
Okay, the person who is presenting that is the Thamaya, right?
Damya, yes, ma'am.
Yes, Thamaya, I would just want to ask the question that how does the hybrid combination of LW and NTRU improves the resistance against the lattice and the quantum attacks? There will be some comparison between the standalone LW or NTRU schemes. Am I audible, Thamaya? Thamaya, am I
Ma'am,
audible?
I'm there.
Are you there?
Yes.
Yes. You missed the question?
No, no.
I asked one question that how does the hybrid combination of LW and NTRU improves the resistance against the lattice and the quantum attack? Is there any comparison between the LW and NTRU schemes?
No, it's a hybrid between learning with error and natural.
These are the natural. Am I right?
I don't understand you. What do you say?
You use the LW and NTRU, right? To improve the
Yes,
efficiency or the resistance.
yes.
Am I audible to you? Yes?
Pardon?
Hello?
Ma'am, you
Hello.
are audible. Both of you
Yes.
are audible.
Ah,
Yes, yes. How
Karen.
how does the hybrid combinations will work on LWE and NTRU to improve the
Yes,
resistance?
yeah.
Yes.
And I'm used K KDF function
Which function?
to combine learning with error and natural.
Okay.
Uh,
So you use the quantum resistance, right?
yes.
So is there any comparison between them?
Comparison with Kyber only
Compared in using
on,
both the LW and NTRU schemes. Is there any
on
comparison?
natural.
Yes.
I make a comparison between Kyber and
Uh-huh.
Netro and hybrid proposal I design it.
Okay. So
Okay.
why is HKDE used to merge the output in the
Um,
LWE?
uh, let me see. To combine the shared key between the natural and learning with error. I used its function.
How does it enhance the robustness?
How does
How
how does
does it enhance the robustness?
it's a hands between السايبر takes الefficiency the security of two implementation was strong because we used learning with error and natural problems enhances the security to post quantum attacks.
Okay. Okay. Thank
It's
you,
good.
Damaya. Yes.
Yes, thank you. Any questions, sir?
No. Thank you.
We welcome.
Thank you so much, Damya, for that
Thank you.
presentation.
Merci.
I would now like to move forward with our next presenter, Habibi Palipiu. I would ask him to present his paper on design and preliminary testing of a sensor-based modular ship prototype for hydrodynamic evaluation. You may please share your screen and start with your presentation.
Can you hear me?
Yes, sir, you're audible.
Yeah. Thank you, Miss. I share right now. Okay. Good afternoon, everyone from Indonesia. My name is Habibi Paripi from Hasanuddin University, Indonesia. And today I will present our work with title Design and Preliminary Testing of a Sensor-Based Modular Ship Prototype for Hydrodynamic Evaluation. This is research propose a low-cost experimental platform for early stage hydrodynamic and performance evaluation. The problem statement from my work, the conventional ship model testing typically required towing tank facilities. But these facilities are very expensive, infrastructure intensive, and not easily accessible. And this is make rapid iteration and early stage experimental validation difficult, especially for my institution without large hydrodynamic laboratories. And this is a fact. And the research gap, although we have seen significant advance in low-cost sensors, embedded system and real-time data acquisition, their application to modular hydrodynamic prototype remain still limited, and there is still a gap between affordable sensing technology and practical hydrostatic experimental platform. The methodology overview. Methodologically, the system consists of four main steps. The first, we design a modular ship prototype equipped with internal ballast tank and 6 ultrasonic sensors. And the second, we collected synchronized time series data to draft related parameters. And then the third, we applied controlled loading scanners, observe draft trim and list responses. And definitely, we conducted a free running test using GPS tracking to evaluate relative performance trend. And the system architecture. So this is slide illustrated the system architecture. 6 ultrasonic sensor send data to microcontroller. The data are logged as time series measurement and statically processed. From this process, we derive hydrostatic and performance indicators. This is the prototype configuration. The prototype consists of modular ballast tank, 6 ultrasonic sensor, a GPS module, and self-propulsion systems. And then the modular configuration allow controlled redistribution of internal load for stability testing. analysis to simulation. This one. The result, balanced loading result, internal. In the first experiment, we evaluate draft response under balanced loading. The internal liquid distribution was arranged systematically in both longitudinal and transverse direction. And the time series measurement from 6 sensors remain stable with drive, confirming steady state condition, and this validates the reliability of the sensor-based draft measurement. And result of trim and list detection. In the second test, we redistributed internal load and to serve trim and list tendencies by combining longitudinal and transverse drafts proxies, and we detect small but consistent difference. This is demonstrated that the distributed sensor arrangement can qualitatively identify from trim and list without complex hydrostatic calculation. And this is particularly useful for early stage stability evaluation. And the result next, speed response. We also conducted the free running test using GPS based position tracking. In Celsius, speed was derived from successive coordinate differences and statically summarized. Although the results are not intended for absolute resistance calculation, but this is research provides reliable relative performance indicators. When combined with the draft and stability analysis, this is creates integrated hydrostatic and dynamic evaluation framework. So, what the conclusion and limitation from this research? In conclusion, we developed a sensor modular prototype capable of early stage hydrostatic and performance evaluation. The system validated draft stability detected from detected trim and list tendencies and established relative speed metrics. Then the proposed framework offer scalable, low-cost experimental platform suitable for exploratory research and engineering education. But this is have limitation. What is this? One important limitation in the result. In the result have not yet been benchmarked against conventional towing tank experiment or validated top full scale hydrodynamics testing. And future work will focus on the comparative validation and expanded experimental scenarios. Thank you very much.
Thank you so much, Habibi.
Yes, Habibi.
Do you have any questions for him?
Yes, Habibi. I want to ask one
Yes,
question to you.
yes, ma'am.
How was the accuracy and calibration of these 6 ultrasonic sensors will be validated for against the any standard? There is some standard measurements are there. Any techniques are there to measure the sensors validated?
Uh, do Hello,
Yes, you are
can you hear
audible.
me?
Yes, yes, yes.
Thank you for question. The objective of this study was not absolute hydrodynamic precision, but consistent and repeatable relative measurement. The sensor were calibrated prior to testing, and steady state time series stability confirm internal consistency. But for full hydrodynamic accuracy, comparison with towing tank facilities will be required with is part of future work. Thank you.
Okay, thank you from my side.
So, Professor Takamatsu, do you have any questions for him?
Oh, yes, but a little bit late, so that I'm no question.
Okay, thank you so much, sir. Thank you, Habibi, for that insightful and well-presented talk.
Yes, thank you, ma'am. Good afternoon from Indonesia.
Yeah, good afternoon to you too. Next, we'd like to move on to our next participant, Tuan Muan Than. I would request him to present his paper on evaluating pre-trained AI models for 3D CT lung nodule detection in hospital data, challenges and adoption insights. You may start your presentation by presenting your screen.
Thank you for your introduction. Let me share my monitor.
Yes.
Can you see my slide?
Yes, sir, we can see your screen.
Okay, let me. Okay, let me proceed. Good morning, good afternoon, and good evening, everyone. My name is Tuấn Nguyễn Thanh, and today I will present our work entitled Evaluating Pre-trained Models for 3D CT Lung Nodule Detection in Hospital Data, Challenges and Adoption Insight. This study was conducted at Ho Chi Minh City University of Technology, Vietnam National University, Ho Chi Minh City. In this presentation, I will focus not only on model performance, but more importantly, on what happens when pre-trained AI models are deployed in the real hospital environment, especially in low-resource settings. We know lung cancer is one of the most prevalent and deadly malignancies worldwide. In Vietnam, it is among the most common cancers, ranking second in
Tunggu
incidence
dulu kalau
in
selesai
male.
nih.
Sorry. And the third among in female. Early detection of early stage pulmonary nodule on CT imaging have been shown to be significantly improve clinical outcome. However, this process heavily relies on expert radiological interpretation. In Vietnam, healthcare systems face several constraints, including a limited number of physicians, with approximately 14 physicians per 10,000 population, and a substantial diagnostic gap between central hospital and local hospital. At the same time, the number of chest CT examinations has increased rapidly, placing additional pressure on radiologists. Meanwhile, retrain this learning model for binary nodule detection has demonstrated strong performance on public benchmark datasets. However, their applicability to real-world clinical data remain insufficiently studied, particularly in a low-resource healthcare system where imaging protocols are highly heterogeneous. Another major challenge in the lack of interoperability between hospital information system and radiology system. This limitation makes the large-scale data collection and annotation extremely difficult and remain a significant barrier to clinical AI adoption. So, our motivation was to evaluate the real-world feasibility of AI-assisted lung nodule detection in resource-constrained hospitals. Specifically, we aim to implement a custom platform integrated with existing hospital systems to improve retrain detection models without relying on the manual expert annotation. By collecting a dataset of 324 3D CT examination automatically labeled from narrative diagnosis report. We also sought to assess performance across multiple red zones and to investigate whether simple anatomical constraints could reduce the false positive. Ultimately, our goals are not only to demonstrate technical feasibility, but also to provide practical insight for clinical deployment. We conducted a retrospective analysis of 324 stress CT scans in standard DICOM format. It accomplished by pre-test Vietnamese diagnostic report. No manual expert annotation were performed. Instead, we developed an automatic keyword-based labeling byline that carefully handle negation and linguistic variation, thereby generating binary routes. All analyses were conducted on anonymized data in accordance with institute review and ethical standards. We evaluate two retrain models, Luna 16 and DLC SD, yield directly without additional fine-tuning on local data. For each city volume, the byline first performs lung segmentation to isolate the pulmonary parenchyma, and the model then conducted either postal level or candidate by screening for pulmonary nodule. Finally, results were consolidated into a binary scale level decision, indicating the presence or absence of at least one pulmonary nodule. Due to the weak nature of the route, our evaluation focused on descriptive performance trend rather than definitive clinical accuracy. We computed performance metrics across 4 confidence red zones: 0.5, 0.8, 0.9, and 0.95. These metrics include accuracy, sensitivity, specificity, resistance, and F1 score. This approach allows us to examine sensitive and specificity trade-off under the related operation constraint. When applied the Luna 16 model, using its default low detection threshold, we observed a large number of erroneous nodal candidates. Out of 8,818 detected candidates, Nearly 60% were located outside the anatomical lung region. In some cases, the model detected suspicious findings entirely outside the lung structure. This clearly indicated that the default region settings are not suitable for real clinical data without anatomical constraints. So we enhance bone lunar system and DLC-SD by incorporating a lung structure by box processing step that filter redirection according to the segment lung smart thereby reduce the number of false positives and improve candidate precision. And this histogram illustrates the distribution of detected nodules within the parenchyma bursitica. At a low threshold, the model operates in the highly sensitive mode, leading to the statistical injury in suspicious candidates. Many of the candidates are likely false positive, highlighting the need of carefully threshold selection and box processing. We then evaluated both models across multiple detection thresholds. Across all thresholds, both models consistently detected between 84 and 96% of true nodules, indicating strong sensitivity and few missed cases. However, specificity remained relatively low, ranging from 9 to 41%, reflecting either over-detection by the model or under-reporting of nodal in the clinical documentation. These findings suggest that retrained models are well suited for screening but require further refinement for clinical decision making. Based on these results, we made the pilot implementation of integrating the AI learned nodal CT model into the medical information system at hospital. The result obtained 60 to 90 seconds for each CT scan. This demonstrates that the AI system is capable of real-time operation and were readily accepted by clinical during the pilot development phase. Although state-of-the-art model performed well on the published dataset, our results show that the real-world clinical deployment presents distinct challenges. By incorporating lung segmentation, we reduce the false positive by nearly 60%. However, model performance remained high dependent on the CT acquisition parameter such as the slice thickness and the reconstruction kernel. Therefore, proper documentation of imaging metadata is essential for the reliable evaluation and development. In the clinical practice, the model are the best position a reading tool to be used in collaboration with radiologists. Our results demonstrate that the retrained models retain the generation potential even when applied to heterogeneous data outside their original training domain. At the same time, this study highlights the limitation of the weekly label data and the need for expert validation in the future work. To avoid the bottleneck in the data annotation, it is critical to use data already generated during routine hospital operation. This requires the interoperability between imaging system and the diagnostic report, enable international standard. Furthermore, AI tools should be integrated directly into the existing clinical workflow with the intuitive interface to ensure adoption by radiologists. Moreover, automated output generation in the form of the structure reporting template using standardized critical terminology such as NOM-CT will support consistent critical document and enable the recent highlight quality dataset for the future model. In conclusion, we evaluate two retrained learned nocture detection model on 324 real-world chest CT scan. While both models demonstrate strong sensitive, but false positive remain a major barrier to clinical adoption. Our pilot implementation show high operational stability, reduce the interpretation time, and positive feedback from radiologists. More importantly, this study provides the real-world evidence that AI system can be integrated into the existing hospital infrastructure at a minimum cost and without the large-scale manual annotation. Thank you very much for your attention. I will be happy to answer any question.
So, ma'am, do you have any questions for him?
No, Pranjal. No question from my side.
I have one question. The
Yeah.
short question. In your abstract, the time the leading time is very quickly. So the tense and the in this case I think how can you determine the time of the leading time by
Yeah.
human?
You sorry, your question is to focus on the time for the suggestion here.
Yeah, the time. So the leading time is it depends on the human, the person.
Yeah,
I think
it depends on it's okay. As you know, the CT scan it depends on some every scan volume maybe about 355 image per study. So yeah, when I calculate the average time, it from 60 to 90 seconds for each volume. Yeah.
Okay, thank you.
Thank you.
Thank you so much for your informative and engaging presentation.
Thank you.
Now, I would like to introduce our next participant, who is Nurshazmeen Izzati Shareen. She would present her paper on meta-rise versus traditional onboarding at MCMC and comparative evaluation of new hire experience and learning outcomes. I would request you to present your presentation and start with it. Nurshazmeen?
Hello, hi. Can you see my screen?
Yes, we can see your screen.
Yeah, right. All right. Assalamualaikum and very good morning, everyone. My name is Nurshazmeen Izzati Sharim. I am postgraduate student from University Technology Petronas. So today I will present my study entitled Meta-rise versus Traditional Onboarding at MCMC. Maybe some of you might wonder who is MCMC. MCMC, or the Malaysian Communication and Multimedia Commission, is a Malaysia's regulatory authority. They are responsible for overseeing telecommunications, broadcasting, digital platforms, and ensuring industry compliance with national policies. As a public sector regulator operating it in a rapidly digitalized environment, MCMC has also begun transforming its internal HR practices. The study comparatively evaluates MetaHRISE, the MCMC metaverse-based onboarding platform, with the traditional onboarding, focusing on the new hire experience and the learning outcome. As organizations shift towards digital transformation, the induction process is no longer just an administrative task. It is a strategic socialization tool. At MCMC, MetaRISE was introduced as a metaverse-based onboarding platform alongside with the traditional classroom induction. However, management faced a critical question. Does this immersive technology actually deliver a better experience and the learning outcome? Or it is merely a visually impressive pilot? This study will provide the evidence-based insight needed to move beyond novelty to disciplined decision-making. The literature showed that effective onboarding should enhance engagement, emotional connection, and knowledge retention. Digital and XR onboarding are commonly evaluated using reaction measures such as satisfaction and engagement, and also to use the learning measures to such as quizzes and knowledge retention. Industry leaders like Accenture, BCG, and Walmart report satisfaction level near 100% and documented performance gains when using the XR. Accenture and Floor proves that can be scaled globally. Unlike traditional briefing, MetaHRISE integrates immersive hardware and interactive system logic. The pedagogical backbone is anchored in Gagne's 9 events of instruction. By embedding tasks, decision path, and immediate feedback, we shift from a linear information dump to an active learning sequence design to enhance connective processing. There are very few studies directly compare immersive onboarding with traditional onboarding within the same organization, especially in the Malaysian public sector. This forms the research gap. On this study, we integrate two frameworks. We use the Kirkpatrick as our primary backbone, as it is recognized standard in Malaysia. We injected the cognitive affective model of immersive learning framework, which is also known as Camille framework, as a secondary lens to specifically account for the unique affective processes like immersion and interactivity. As you can see at the top left corner, the Kirkpatrick framework provides the evaluation structure on the onboarding training. In this project, we only focus level 1 reaction and level 2 the learning because it is straightforward to measure and provide the necessary early evidence to determine if a new program is right on track. You also might wonder why I didn't touch on the level 3 and level 4 in my study. It is to keep the project focused, manageable, and directly actionable for NCMC, and also I will keep this area as my future focus. On the bottom left side of the slide, the Camille framework explains how immersive elements may enhance engagement through present and active involvement. It works as supporting lens to help interpret why immersive formats might produce different reaction patterns compared to traditional ones. It explains how VR can increase situational interest, intrinsic motivation, and self-efficacy. For this study, I used the mixed method comparative design. 2 cohorts were analyzed. There are 38 participants for traditional classroom onboarding and 38 participants from the MetaHRISE. The data was collected through KPI survey, Net Promoter Score, and the standardized knowledge quizzes on MCMC corporate mandate. Also, and then after that, we analyzed involved descriptive comparison and simple thematic grouping to support the interpretation. From the survey result, we can see the traditional onboarding recorded approximately of 89% overall satisfaction. Participants appreciated the clarity, reassurance, and the visible HR support. However, the qualitative feedback identifies significant pain points. Session was perceived as presentation heavy with limited interaction. Also, weak coverage of division-specific role that leads to lack of excitement for new hires on the first day. Without a clear picture of their responsibilities or how their division connects to others, new hires struggle to feel the motivation and engage from the start. As you can see here, the MetaHRISE delivered a clear uplift, achieving a 93% satisfaction. Participants described it as fun, exciting, memorable, and emotional connection. However, the primary challenges that were highlighted, including the lag, glitches, the need for sharper graphics, and additional guidance for non-gamers. For the learning outcome result, both cohorts performed similarly. As you can see, traditional score approximately of 82%, while Meta-HRS score approximately of 80%. This indicates no penalty to learning when using the metaverse. Data suggests that remaining gaps in knowledge are due to content complexity rather than delivery mode itself. Looking at the overall pattern, Meta-HRS delivered a clear uplift in experience and engagement by achieving a net promoter score of positive 56, while maintaining the learning priority at approximately of 80%. This outcome aligns perfectly with the global benchmarks in our literature review from leaders like ICICT and Woman, which show the high satisfaction alongside stable performance. As suggested by the Camel framework, this result prove that immersive environment can significantly heighten the emotional connection without compromising core knowledge transfer. Okay, then I benchmark Meta-HRS against the selected global XR onboarding cases such as ICICT VCG and Walmart. Globally, immersive onboarding consistently reports very high satisfaction and engagement, typically around the 90% range. Meta-HRS aligns with this pattern with approximately of 93% of for overall experience KPI and strong NPS result. However, some large-scale global cases report measurable learning uplift, which Meta-HRS has not yet demonstrated it. Therefore, Meta-HRS is already competitive in experience, but there is a room to strengthen learning depth. Based on the findings, I have proposed 4 recommendations. First is to strengthen the hybrid onboarding model by clearly integrating a traditional and immersive component. Second is to re-engineer Meta-HRS content to deepen the scenario-based learning and improve the usability. Third is to explore extending Meta-HRS into pre-boarding to enhance early engagement for the new hire. And fourth, to position Meta-HRS as a global reference point by consolidating it into a robust, evidence-based immersive onboarding model that can be showcased alongside with the global XR practices. In conclusion, Meta-HRS is more than a novel experiment. It is a strategic asset. It proves that MCMC is not just regulating the digital future, but leaving it within its own walls. By adapting a governed evidence hybrid journey, MCMC can continue to lead digital HR transformation in Malaysia. With that final slide, I have come to end of my presentation. Thank you for your attention. Now I welcome any feedback regarding study.
Thank you very much. Can I question?
Yes.
Yeah, so it is very interesting, the relationship to the Kirkpatrick model. The already you said the Kirkpatrick level 1 and 2 so easy to measure. So you in your research you use level 1 and level 2 only. So in the future, your research apply the level 3 or level 4. Well, in this case, so what KPI or something do you plan?
What KPI that I have performed in this study, you mean, sir?
Yeah, in the future. So I understand that 1 and 2 is easy to measure using a KPI.
Yes, in the future, we would like to see on the KPI on the behavior, how they react during after 3 months, 6 months of the employment on the on the mandates of the NCMC, because it is quite longitudinal of practice. On the research on the behavior of level 3. It requires the KPI requires a very thorough discussion because for now I didn't do any KPI setting for the behavior, but in future I will work with my research team on what are the KPIs for the behavior that we need to measure.
Thank you. You said the reason is too long.
Yes, longitude is about 3 to 6 because that is the crucial period where we want to see how new hire behave, how new hire adapt in the working culture at the MCMC.
Thank you.
Thank you, sir.
Thank you so much. Ma'am, do you have any questions for her?
No questions. Thank you.
Thank you.
Thank you so much, Nur Shazmeen, for
Thank you.
such a beautiful presentation and the knowledge that you shared with us.
Sorry.
Yeah.
Let me-
Okay. Let's move on to our next presenter. I would like to call upon Kumari Nidhi Lal to present her paper on real-time detection and outcome analysis of cache poisoning attacks in information-centric networks using machine learning algorithms. You may present your paper by presenting your screen.
Okay, ma'am. Is my voice is audible?
Yes, you're audible.
Okay. Make it full screen. Okay, good afternoon, all of you. So the topic of the presentation is real-time detection and outcome analysis of cache poisoning attacks in information-centric networks using machine learning algorithms. Next slide. So this is the introduction one. Before going to the main part, we first understand about the information-centric networking concept. So this ICN is very different from the current IP-based network. In the IP-based network, we have TCP/IP, UDP to maintain the communication, as well as handshaking protocols is there. But the ICN theory is somehow different. ICN is focused on the content retrieval. So users, all the users which inside the ICN have to make the interest packet. In the interest packet, they have to put the content name to that they want to retrieve from the website or certain server. And then the interest packet is going to transfer towards the router. Then the router is going to forward to another router. Now there are certain additional functionality towards the router of ICN. The routers of ICN having three data structure. The first one is the content store, which is a very important data structure for the ICN to building upon. This data structure content store is used to store the content items for the future access. In this way, the server heat reduction ratio is going to reduce, as well as the host reduction ratio is also going to reduce. We can say some optimization of the cost reduction is happening in terms of the ICN. And the second data structure is the forwarding information base. Forwarding information base is just like the IP-based routing protocol, the forwarding table, in which they can see the outgoing interfaces such that the interest packet can be forwarded further. The third important thing is about the pending interest table, that is PIT. So PIT is used to track the incoming interfaces, and PIT is basically used to identify that which users are making the duplicate request. If the user is making so many requests for one content, so it will take only one content request and rest of the content request will get actually dropped by the PIT. So this is how the ICN will work. ICN is a not host-based communication infrastructure. It is based upon the content redistribution. Now, what is the problem? The ICN is fast, no issue over there. But ICN suffers from some security vulnerabilities. The first most serious attack is about the cache poisoning attack, CPA. So our paper is going to provide the solution for that cache poisoning attack. So before providing the solution, we have to first detect that cache poisoning attack. So let's understand about the cache poisoning attack. Next slide. Yes, as per the definitions, CPA, cache poisoning attack is a high impact security threat in ICN, where the malicious attacker injects malicious or fake data packets into the network's distributed caches. So as I told you that the ICN router having the content store, and this content store is used to cache the content. Now, what the thing is there, whatever the data packets is generated from the server, it is nothing but the fake data. So router is not able to distinguish that which one is the genuine data and which one is the fake one data. So that's why, because all of the things like the creation of the digital signature, creation of the public keys is also very simple in today's era. So due to this you can say separation between the fake and the real one data packets, the router will going to store these fake data packets in its content store. Now where the problem starts, because the cache is full of poisoned attack, it combines of fake attack fake packet data as well as the real packet. So what are the core vulnerability? Core vulnerability says that CP exploit the lack of mandatory wire speed integrity verification in standard ICN deployments. Now, this type of attack comes under the category of distributed denial of service attack, because once the data is distributed among the network, one router is cache the fake data and it is forwarding to another router, and that router is also wants to cache that content, then that second router can also cache and vulnerable to the CPA attack. So this is how the whole complete network can be under the attack, and this is you can say the one type of distributed denial of service attack. Next. Now, what are the mechanisms? So there are certain mechanism in the literature server we have used. The first one is interest interception. The interest interception means nothing but we have to monitor the interest packet, but the monitor of each interest packet from the user point of view is not so much possible. That's why we have utilized the machine learning algorithm. They can analysis the pattern of the incoming and outgoing interest packets as well as the data packets for speedy decision. Primitive injection, the race condition. So for that optimization, fake packets are often smaller in sizes. So as I told you, the machine learning algorithms are used to identify the patterns. So one of the patterns can be, you can say, the data packet size. Obviously, the fake content data having some shortcuts like 1 KB or 1 byte. So this type of pattern is there in the data packet. When there is no actual data, it is only the shortcut, or you can say the empty data packet. It is comes under the fake packets. Content store poisoning. The subsequent legitimate data is discarded as the pending request is already satisfied. Then autonomous propagation. The infected router now serves the poison content to all of the future requesting consumers, and they can allow the spreading the data without any attacker intervention. So this is how the CPA occurs in the ICM. Next. So what are the impact on ISIN performance? So what is the need of that basically? Because first we need to understand what the network is without attack and what the network will perform with attack. So that's why this ISIN performance impact first have to be measured out. So CP leads to systematic failure of the network efficiency, because as I told you, it is a type of denial of service attack. So network efficiency can be drastically dropped. Negative hope reduction ratio also, because if the user is not satisfied with the fake contents, then he or she has to request the content or generate the interest packet so many times. So in that case, the overall interest will be reaches to the server. When the server is getting overloaded, then it will be get high negative impact over the hope reduction ratio. Obviously, cache degradation. If the customer is not satisfied, then all the interest packet going towards the server, then the routing hit that the router is actually serving, or you can say sending the data packet towards a user, is getting low count. Increasing latency. When the first time the data packet is not satisfied, then second time or third time the user has to attempt to get the actual data. So it is nothing but increasing of the latency. That's why the average document retrieval time is also increasing. Energy and resource waste, obviously, because the computational cycles in order to do the repetition of the data, repetition fetching of the data from the server is getting wastage of the resources, the wastage of the bandwidth, and the cost is getting very high due to the invalid traffic and due to the very, you can say, dynamic related fluctuation type of traffic. Next. So why detection of CPA is critical? CPA is critical because somehow it is linked to the IFA attack, that is interest flooding attack. So because of their similarity, in the CPA we are actually capturing the data itself, but in the IFA we are capturing the pattern of the interest packet. So autonomous propagation is one of the, you can say, importance to detect the CPA in the ISIN scenarios. Next. So this is the literature survey we have done in order to create the research gap or to find out the proper research gap and the effective solutions for that. So the first one is proposed by Ding at 2024. They have identified the problem of content loss, that is the fake data injection, and the limitation is this very high computation overhead. The second one is the cache degradation hit ratio drops, and the limitation of that work is a significant network overhead. So you can see in overall the network overhead is getting higher to their proposed work. So we are going to propose that solution that is actually the low cost. The network should not get overloaded, as well as there is a fast detection of CPE. Next. So now I'm hand over to the session to my scholar, that is Shakya. So Shakya will elaborate from there, objective of the paper. Yeah, Shakya, you can continue from there. Are you there? Shaika?
Yes, ma'am. Good
Yes.
afternoon, everyone. Am I audible to everyone?
Yes, you can. You are audible. You can continue with the objectives.
Okay. Good afternoon, everyone. I am Shaika Khan, and I'm continuing the further the stated topic discussed by my supervisor Nidhi Lal ma'am. The further I'm presenting is the objective of my paper, what we have done in the research. As discussed, the ICN is probe vulnerable to the CPA attacks. So we need a lightweight and less computation overhead mechanism to detect the cache poisoning attack in the ICN environment. This paper focuses on comparative evaluation of existing machine learning models within a newly designed ICN specific CPA detection framework. Now, what we are doing in our in research is not only we identified or detect the cache poisoning attack in the ICN environment, but we evaluate the different mechanism, different machine learning algorithm which are available and be used to identify and detect the machine learning algorithm and chooses the best optimal chooses the best option from the listed one. So what we have done, we designed a one framework. It is an end-to-end feature-driven mechanism learning framework which involves the 5 stages. First, we simulate an ICN environment where both normal traffic and cache poisoning attack scenarios are generated. In the second phase, we perform CPA-specific feature
so sorry to
extraction.
interrupt, but your time is up. I would request you to conclude your presentation.
Okay, so in my work, we have designed one framework where we incorporated the
Go to the next slide, Shaika. Go to the
Okay.
next slide. Time is up.
Okay.
Right? Yes. Next slide.
Okay.
Yes. Explain the graphs, results, and then conclude.
Okay. So in our research paper, we took the few algorithms, decision tree algorithm, XGBoost algorithm, and MLP algorithm, machine learning algorithm, and we provide some features extracted from the ICN cache attack and evaluate the cache poisoning happen in the ICN environment, and then perform the best comparative analysis over all the study, all the results, and find out which machine learning algorithm will be best to detect the cache poisoning attack. Here are some graphs of our research project, which first graph is showcase that average latency hop reduction, where we can say that the x-axis is denoted the machine learning algorithm, and the y-axis is the reading features that we have provided, and it clearly visible that few algorithms has the lowest result wherever where the few that the algorithms results that average latency reduced and with cache poisoning attack. And in the hop reduction ratio and interest packet request ratio, same access and iteration will be performed both. After identifying the cache poisoning attack, we evaluate which algorithm will give the best result by doing the feature importance performance comparison. These are the comparison over which we identified that the random forest algorithm is an algorithm, machine learning algorithm, which provide the best result over the studies. Here are some references, and I conclude that in my research analysis, which is the comparative analysis of cache poisoning attack with machine learning algorithm, I identified that after applying multiple feature extraction techniques and evaluation parameters, we identified that random forest algorithm is the best suited algorithm for detecting the cache poisoning attack. And here are some references, and I would like to answer if any question are asked.
Yes,
Thank you
can
so
I
much.
ask one question? Am I audible?
Yes,
ma'am.
you're audible.
Yes. How was the data set for cache poisoning attacks, the detection generated and labeled?
Ma'am, your voice is disturbing.
Now cleared?
Yes, ma'am.
How was the data set for cache poisoning attack detection generated and labeled?
Ma'am, it is generated from the environment. We have designed one framework where we simulate the ICN environment and cache poisoning attack environment, and from there we generate the data set, and then that generated data set we perform the feature engineering and given to the machine learning algorithms.
Okay. Thank you.
Thank you so much, ma'am.
Thank you so much. Sir, do you have any questions for her?
Oh, thank you very much.
Thank you so much.
Thank you for such an impactful presentation.
Thank you so much.
Now, I'd like to move on to our next participant. That would be Maria Spikova. She'll be presenting her paper on visualization for the CIS benchmark scanning results. I would invite you to present your paper.
Hello, everyone.
Yes,
Finally,
your screen is visible now, Maria.
wonderful. So, hello, everyone. My name is Dr. Maria Spichkova. I'm a senior lecturer at the IMIT University in Melbourne, Australia. And today I will be presenting our work on visualization for the CIS benchmark scanning results. This project was conducted with my team, with Chanchura Chow, Dutch Chamkaval, Julie Kulkari, Sahil Singha, Muhammad Sukelfi, and Pradhuman Khandelwal, who are students of mine. Motivation for this work is, well, we use a lot of software. The use of computing technologies is increasing. And also at the same time, systems that we are using, they're becoming more and more exposed to cyber attacks. And well, we need to do something with this. And if you speak about computing technologies, computer software, we also observe that nowadays there is a big shift to cloud platforms, to AWS, to Google platforms, etc. And well, for this, we need to have also some solution to make sure that the cloud-based solutions are secure. And the Center for Internet Security, CIS, provided a set of benchmark guidelines. They are very helpful, but if we try to have manual compliance, this is very time-consuming and resource intensive. So this is difficult and time-consuming. We need to have some automation. And if we do automation of the compliance check, we also need to make sure that the results are easy to understand for the corresponding users. What do we understand under CIS benchmarks? These are benchmarks developed by the Center for Internet Security, which is a non-profit organization whose aim is to improve internet security by improving the awareness of the corresponding issues and by providing the set of benchmarks and software solutions. So they provide best practice security configuration guidelines. They help to include rationale, impact, audit steps, and remediation steps. The guidelines they provide, they are available for multiple cloud platforms and services, including Amazon Web Services, Google Cloud, etc. And they also actively monitor emerging threats and provide regular updates. The research gap that we have currently is that, well, there is a big body of work on the CIS compliance automation, but there is limited focus on intuitive risk-oriented visualization of the results of scanning. Also, most of the existing AWS tools operate on single accounts, and there is a need for multi-account automated visual analysis. The core contributions of our study, well, we first of all conducted the systematic review of studies related to the CIS benchmark adoption, and we also elaborated a prototype graph-secure application that can run on multiple AWS accounts, analyze how these accounts whether these accounts are secure. They can validate these accounts against multiple CIS benchmarks, and based on the results, GraphSecure can provide recommendations to overcome the identified issues so that the security threat can be eliminated. So the GraphSecure provides an automated approach and it helps reduce the maintenance overhead and lower the technical barriers to effective security assessment. This means we focus especially on novice developers who might be especially vulnerable to this case, that they might also miss something or misinterpret some results of scanning. And we believe that with our tool, they will be not misinterpret the results. Because GraphSecure focuses on visualizing identified issues and on the support in informed decisions how to fix the corresponding issues. In our systematic literature review, we conducted a search in Google Scholar and Scopus. Our search terms were pretty simple: CIS and security. And the second term was CIS benchmark. Inclusion criteria were also rather simple. The publication have to be written in English, and they should be focused on CIS benchmark application or analysis. We excluded publications that were not written in English, that do not cover the topic of interest. We also excluded all the duplicated publications. We excluded interviews, prefaces, reviews, posters, panel discussion, etc. So all the publications that are not peer-reviewed And we also excluded the papers that aren't accessible online. As a result, we identified 17 relevant publications. In our search, we haven't set any time frame for the search, but the first paper that we identified was dated 2017. And we conducted the search at the end of the last year, so the last publications were from 2025. We also observed increased research interest over the recent years, while however the interest was pretty modest, as you can see by the numbers. And from these 17 publications, we identified 3 core research directions that were covered by these papers. First of all, CIS-based security assessments, then CIS compliance automations frameworks and tools, and development of new or refined CIS benchmarks. And the second point was especially interesting to us. What we observed there, that there is limited attention to intuitive risk-oriented visualization of CIS compliance outcomes for cloud users. And we thought that this is very important research gap because we believe in visualization of the data, that it really improves the overall results. Therefore, we proposed GraphSecure, which is a web-based prototype. This web application allows for CIS benchmark scanning on AWS, and it supports multiple AWS accounts. It provides automated validation against multiple CIS categories. This prototype has visual dashboards, and in these dashboards, the user also can get recommendations related to the identified issues. So the focus here is on usability of the application. The system architecture is presented on these slides. We focused on serverless solution using AWS services. The front end was developed using React.js with TypeScript. The backend was JavaScript for CIS execution. As database, we selected DynamoDB, and the infrastructure was AWS CloudFormation. The workflow was deliberately simple. First of all, the user should log in, obviously, and then the user will see the dashboard. On the dashboard, the previously run results of the scans will be presented. On the same dashboard, the user can start new scan by selecting corresponding CIS categories. Then, after the scanning results are available, the new results will be presented, and they will be also stored to be retrieved from the database and again to be presented in the dashboard. On this slide, you can see a few examples of the screenshots. On the top, you can see the main dashboard with a chart for failed benchmark by category. And you can also see the history page with the scan record, the extract of it, which focused on the table data. And on this screenshot, you can see the launch screen where the user can select the types of the benchmark to be checked for. And as you can see, the interface of this prototype is simple. The goal is to provide truly simple interface, which will be fast to use by novice developers. And what we see as the advantages of GraphSecure are, there are similar, the tool provides similar automation capabilities as the prior tools, but GraphSecure supports multiple AWS accounts, which is the rare feature. and it has strong emphasis on visual clarity, on providing the dashboard with the corresponding visualization. Also, this tool enhances practical usability of compliance data by providing step-by-step remediation guidance, which is especially accessible for novice developers. It reduces technical barriers to security assessments, it improves readability of compliance results, and support informed decision-making. To sum up, in this paper, we present two core results: systematic review of studies related to CIS benchmark adoption, and we present our prototype GraphSecure for automated CIS-based AWS security assessment, which can be run over multiple AWS accounts and which provides also visual dashboard and the remediation recommendations. Last but not least, I would like to mention that this work was conducted in collaboration with Shine Solution Group. And that's all. Thank you very much. If you have any questions, I'm happy to answer them. I hope I was on time.
So, ma'am, do you have any questions for her? It seems they don't have any questions for you. Thank you so much for your time and effort in presenting such an amazing presentation.
Thank you very much. Thank you for sharing this session.
Thank you. Moving forward, I would like to conclude this session. I sincerely thank our authors for their excellent presentations and valuable contributions to this session, and all our participants for being a part of this international conference. I hope this session was informative and enriching for everyone. All the presenters will receive their digital certificates via email within 2 working days. The publication will be live within 7 to 8 months. Kindly cooperate with the ICICT 2026 team. On behalf of the entire team, thank you for your continued support through the 11th edition and all the previous editions. We look forward to welcoming you again for the 12th edition in 2027. Now, as a token of appreciation from the ICICT 2026, I would like to present our judges with the certificate on behalf of the team and Global Knowledge Research Foundation and partners. I would like to invite our session chair, Professor Kunihiko Takamatsu, to give the closing remarks.
Thank you, all presenter. I appreciate your presentation. Thank you very much. Very enjoyed. Thank you.
Thank you so much, sir. Next, I would like to call upon Professor Ishwari Raskar to give her closing remarks. Since I think Professor Ishwari is not there with us, I would extend my sincere gratitude to our session chairs for chairing this session with great energy and for their valuable presence and guidance throughout. I would kindly request all of you to switch on your cameras for a quick snapshot of the virtual conference for valuable memories to display on the conference website. If everybody can please switch on their cameras. Smile, everyone. Thank you, everyone, for such a wonderful event. Stay safe. Take care. Bye-bye.
Thank you.
Thank you so much.
Thank you very much.
Thank you. Bye.
Goodbye.
Bye-bye.